Well, in the last example, we finished this question. Now let's move on to the next question, which is from 2001 CE. Now, the question says that the uniform plank of weight 450 Newton rests on two trestles X and Y, and the worker of weight 675 Newton stands at one end of the plank, as shown below. Now, the worker holds the light basket which contains several packets of goods, each of weight 6 Newton. What is the maximum number of packets he can hold without tilting the plank? Assume that the weight of the plank acts through its center. Okay. Now let's draw a three-body diagram of the plank. Now we call the reaction provided by the trestle X R1 and that provided by the trestle Y R2. And we call the weight of the worker together with the packets, we call it W. So when the plank is about to tilt, it tilts in a way that it rotates in a clockwise manner about Y, and so the plank will leave the trestle X, so R1 is equal to 0. So now with that we can take moment above the support point of the right trestle, which is point Y. We take moment about point Y. So the sum of clockwise moments is equal to the sum of clockwise anticlockwise moments. So W is providing the clockwise moment. Its moment is the weight W times the moment arm, which is 1.5 meters. And the 400 Newton is providing the anti-clockwise moment. So its moment is 450 times the length, which should be half of 5 meters, which is 2.5 meters. So solving this, we get W equal to 750 newtons. But the weight of the worker is only 675 newtons. So the weight of the packets should be the difference of 750 and 675. Divided by 6, the weight of one packet, we get 12.5 as the number of packets. So when the number of packets is 13, the plank tilts. So the maximum number the worker can hold is only 12. So the answer should be 12, which is B. The answer should be B. Now with that, we come to the next example, which is a question from 1990 CE. Now in the figure at the right, the uniform meter ruler is of weight 1 Newton. Of weight 1 Newton is balanced horizontally. So we've got to find the tension T. Now look, check, there is an unknown weight W. Maybe from some object not shown here, and the 1 Newton should act at the center. Is the weight of the meter rule. Now let me capture this diagram. So let me use spring brush. So let's draw a free body diagram for this ruler. Okay, the free body diagram should look something like this, but there should be one more force not drawn here. So we draw it. So the force, the weight of the ruler should act at the center. So we got an unknown weight. We got a weight of 1 Newton. Okay, let's make it bold. So this is the free body diagram of the of the ruler. So we take moment about the midpoint. So the sum of clockwise moments equal to the sum of anti-clockwise moment. So sum of. So for the clockwise moment, there's only one force providing it. It is the unknown weight W of an unknown object, and the 6 Newton is providing the anti-clockwise moment, and the moment arm is 20 cm, which is 0.2 meters. Now solving that, we get W equal to 2.4 meters. So therefore the net force equal to 0. We get the outward force, which is tension, equal to the sum of the 3 downward forces, which is 6 Newton, 1 Newton, and the calculated W, which is 2.4 Newton, and we get T equal to 9.4 Newtons. Now there is another method. Just to illustrate that we can take moment about any point. So this time we take moment. So we take moment. This time we take moment about the right end. Oh, see, RIGH, the right end. So the sum of clockwise moments equal to the sum of the anti-clockwise moment. So for the right end, if we take moment about the right end, the only force which can provide the clockwise moment is the tension T. So we get tension times the moment arm, which is 0.5 meter, should equal to the sum of anti-clockwise moment. So the 1 Newton has got a moment arm also 0.5, and the 6 Newton has got a moment arm of what? Oh, what is it? 0.7, isn't it? 0.7 meters. Okay, so with that we get 0.5 tension is equal to, the first term is 0.5, the second term is 4.2. Altogether we get 4.7. So therefore tension is equal to 4.7. We multiply both sides by 2 times 2, which is equal to 9.4 Newton. So you see, we can, no, this is not necessary. So we can take moment alternative method. So we can take moment about the right end to find the answer, and find the answer at one go of taking moment. So until next movie, let's take a